Hello, so let's just walk through the code a little bit so you can see what the provided code files are like. The first one we look at is the parent microbit. So this is a pre-written piece of code. You can always set this as an activity to develop the code yourself if you want to. But if you are doing this as perhaps just a design and technology build activity, then you can provide this code and just load it onto the parent microbits. So the way this works is that when you press the A button, it will send a little radio message that the gate and the child will receive. And if you press the B button, then it will scroll the unique device code on this so that you can program that into the child bit and into the gate microbit. So device name is the one that is the little block that gives you the unique code that is unique to every single microbit, globally unique to all microbits. When the program starts, it sets a radio group to 5. That could be any number in the range of 1 to 255. It just means if you've got other activities going on at the same time, they won't interfere with each other. And all the IET activities have been coded with different radio groups in them so that if you were doing a number of different activities in the class at the same time, they wouldn't interfere. P just shows you it's a parent microbit. If you've got lots of microbits kicking around in the classroom, knowing that one's the parent, one's the gate, and one's the child is a lot easier. So we just get it to display a character on the start. When you press the A button, it sends the device name of this device, and it's sent as a broadcast message on radio group 5, shows the little stick person icon, and then after a short delay, which is built into the show icon, it shows the P again. So it's always got the P on the display. For setting up the system, you want to know what the unique device code is. So you press the B button and it scrolls the device text across the screen and then it goes back to P. So it's quite a simple program there. You don't have to change this at all. It self-adapts to the different device codes of the different microbits. So that's probably the simplest piece of code. Now let's talk through the gate example. So this is one that perhaps the teacher might just load onto a single microbit. You can see that the simulator works really well because it shows you a little example servo here as well. Let me just make this screen over here so we can see the code a bit. So this code is a bit more involved. You don't necessarily have to write this code yourself. Again, all code is provided. So when it starts, it's on radio group 5. It has this array called parents, and I've pre-coded it with the device name of the parent microbit that was used in the demo. But you can press the add and you can add other device codes in there. So you've had 15 different pairs of parent and children in the classroom, then you could put in 15 different unique codes there. We put the detail of the code in little functions just so it's a bit easier to see what the code is. So when you press button A, it closes the gate. Press button B, it opens the gate. So A and B will allow you to test that the servo motor is working properly. And if you press A and B together, then it reacts as if an unrecognised parent has arrived at the gate. So normally that would close the gate, open the gate, and that will deny access. If we then look at what happens when a radio message is received, and again, remember that all this code is provided, you probably won't necessarily do anything with this code apart from come up to the top bit and put some extra codes in there. It's useful to know how these things work. When it receives a message, it says, well, if the message you received appears in the list of parents, then it opens the gate, waits 2 seconds and closes the gate. Otherwise, it denies access. Open a gate basically moves the servo on pin P1 to 90 degrees and also displays this little icon. And close gate moves the servo back to 0 degrees and shows the little closed gate icon. And what denied does, so if you have a parent microbit that isn't listed in that list here of acceptable parent microbits, it displays an X and it goes and then closes. Make sure the gate is definitely closed. So really the only thing you would need to change in here if you were building a bigger class of parents and children is to get all the unique codes of all the parent microbits by pressing the B buttons and writing those down, and then add them to this array. And then you download that to your gate microbit, and you either use it just with the on-screen animation, or you plug in a little servo motor. The final piece of code, this is slightly simpler than the gate. Again, it works on radio group 5. So if you have other activities going on in the classroom on different radio groups, it won't interfere. This I've customized, so the POTIG is the unique code of the child microbit in, the parent microbit in the demo I gave. So it sets the parent to POTIG. So this child will only respond to a parent that sends its device ID as POTIG. And then we display the letter C, so we know that this is a child microbit, so we don't confuse the child microbits and the parent microbits when they're all lying around the classroom. When the child microbit receives a message, it says, if the message I've received is the code of my parent, I'll play the hello sound, which goes ooh, and displays the little stick figure, waits for 1 second, and then displays the C icon again, so that your microbit is always identifiable as a child microbit. If it receives a message that it doesn't recognise, it does nothing at all, which you'd expect. So that's the code. Those 3 code files are provided on the IET website. You can download them download them as a hex file, drag and drop them into MakeCode, and then you can modify the code and then download them onto your microbits. There is a starter activity inside the PowerPoint presentation that you can use to get the children to do a tiny bit of coding, which basically gets them to send a message from one microbit to another, and that might help them to understand and to experiment with how radio messaging works. And then you can lead into this bigger activity to build a whole class demonstration. So I hope that gives you a bit of an idea of how the code works and things that you can change with it.